Hi guys, welcome back to my channel. You know that in my previous videos I have discussed the shape of the molecules, but I didn't start the shape of the ions. I've discussed tetrahedral shape, uh, uh, trigonal pyramidal shape, bend shape or V shape, trigonal planar shape, trigonal bipyramidal shape, octahedral shape. Let's continue some more example of shape of the molecules. Look at that one. I've already discussed SF6, which is octahedral. Now SF4. What is the shape and bond angle of SF4? Let's do the SF4 molecule. Sulfur tetrafluoride, SF4. Shape and bond angle of SF4. Do you have any idea about the shape and bond angle of SF4? Let me draw first. Sulfur is the central atom. 2 fluorine. Sulfur has 6 valence electron. 1 goes back into the white boat or the behind the boat, and one is like this, like a wedge. F F. Sulfur has 6. 1, 2, 3, 4, a 5 and a 6. 2 electron left on it. So let me know what's the shape. Any idea? So it looked like a seesaw shape. One bond angle is 86.5, and one is 102. Okay. Now I have some more molecule like chlorine chlorine trifluoride. Let's see the chlorine trifluoride. Look, chlorine trifluoride. Chlorine has 7 valence electron, and then make 3 bond with fluorine, 1, a 2, a 3. 3 bond with fluorine. How many electron left? 1, 2, 3 gone. 4, 5, 6, 7. How the shape looks to you guys? T shape, important. That was a past paper question. T shape, T shape. Bond angle 87.5. Now some more molecule like chlorine pentafluoride, like chlorine trifluoride. In the same way, chlorine pentafluoride. Look at the shape and bond angle of chlorine pentafluoride. Yeah, let's see the bond angle and the bond angle and shape of the chlorine pentafluoride. Okay, chlorine pentafluoride. Look at the chlorine. Chlorine has 7 valence electron in the outer shell. So one, look at that. Chlorine, one bond here, one bond here, one here, one here, one at the top. Fluorine, 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 fluorine. Yeah. How the molecule looks to you? Isn't it like a pyramidal shape? Like it's like a pyramid. Like a pyramid. So in case of ammonia, we have seen trigonal pyramidal, but this is square planar pyramidal. Yeah, unique molecule, very unique molecule. Square planar pyramid. and the bond angle is 90 degree, guys. 90. BA bond angle 90 degree. Now, so we have done Cl3 chlorine trifluoride T shape, Cl5 square planar pyramidal. Now xenon tetrafluoride. Look at the xenon tetrafluoride. XeF4 xenon tetrafluoride. What is the shape and bond angle? Xenon tetrafluoride. XeF4. Look at that. Xenon has 6 valence electron. So that 2 bond coming out of the plane with a thick wedge, and this is the dotted wedge going behind the board or behind the plane. A fluorine, and a 2 lone pair. This is the plane and 2 lone pair. One at the top, one at the bottom. The arrangement of those 2 lone pair will not affect the bond angle and the geometry. Look how it looks to you guys. This is at the bottom. This lone pair at the bottom, that lone pair at the top. So it's like a plane. It's like a plane molecule. One lone pair at the top, one lone pair at the bottom. The arrangement of the lone pair is in such a way that it won't create any lone pair bond pair repulsion. The bond angle is 90 degree. 90 BA bond angle 90 degree, and the shape of the molecule, any guesses? Square planar. Yep. Now SO3 and SO2. Let's do the SO3 molecule, sulfur trioxide and sulfur dioxide. Shape and bond angle of SO2 and SO3. Shape and bond angle of SO2 and SO3. Sulfur trioxide and sulfur dioxide. I want to compare. Look at that. Sulfur has how many electrons in the valence shell? 6. And oxygen make always a 2 bond, double bond. Oxygen is a divalent, so it always make a double bond with the sulfur. SO3. I told you 3 bond pair and a non-lone pair. I told you you have to ignore pi bond. Trigonal, planar. But the bond angle is not exactly 120. It's greater than 120. So you can put like greater than 120 degree. Now SO2, sulfur dioxide, 2 double bond. Sulfur has 1, 2, 3, 4, 5, 6 lone pair. Yeah, in that case, the pi bond and a lone pair, there will be no repulsion between the pi bond and a lone pair. So the bond angle is 120 degree, but the shape is not trigonal planar. It is like a bent shape. 120 degree, and the shape of the molecule bent. Here the lone pair and the double bond will not cause any repulsion. So that's why the bond angle is 120 degree. But the normal bent molecule, the bond angle is, in case of the normal bent molecule, the bond angle is 104.5. Look at the water molecule, which is a bent molecule, and it has 2 lone pair. And that molecule has a maximum lone pair bond pair repulsion. That's why the bond angle further decreased from 107 to 104.5. 104.5. The bond angle in ammonia is 107 because of the presence of 1 lone pair. Okay, now let's see shape of ions. Ions, they have either positive charge or negative charge. How those positive charge and a negative charge affect the geometry and a bond angle? Let's see. Normally, the positive charge has no influence, guys. Like a pi bond, like a double bond and a triple bond, there is no effect of positive charge on the shape and the bond angle. Now, but the negative charge, that causes a repulsion, because the negative charge is nothing but a pair of electrons. So because of the presence of the negative charge on any molecule or any ion, that distort the bond angle, distorted means change its bond angle, and also affect the shape of the molecule. Let's see. First, we will do with ammonium positive ions. Ammonium ion, NH4 plus. Whenever we have a positive charge, we end by em, ammonium. Shape and bond angle of ammonium. Ammonium. It has a dative bonds. Ammonia has a 3 covalent bond. Ammonium ion has a 1 dative bond. So I have already discussed that ammonium ion in my previous video. Now let's see the shape and a bond angle. Now look at the ammonia. It has 3 bonded pair of electron with 1 lone pair. Agree? It has 3 bonded pair and 1 lone pair. Whatever the lone pair it has, it is donated to hydrogen. Now, with the positive charge, because nitrogen lost a pair of electrons. Now, look at that. In this case, nitrogen make 4 bonded pair of electron and no lone pair, which is closely look to the methane molecule. Like look at the methane molecule. We have to always go back and check our parent compound. It look like our parent, one of the parent compounds. So central atom, don't worry about the carbon and a nitrogen, but in case of methane, central atom has 4 bonded pair of electron and no lone pair. I told you, if a central atom has 4 bonded pair of electron and a no lone pair, then the shape of the molecule is, any idea? Tetrahedral. And what is the bond angle? 109. 109.5. Shape it's same as methane molecule, tetrahedral, and a bond angle 109.5. Okay, ammonium ion. Why the ammonium ion is related to methane? Because of the same condition. What's the condition? Don't worry about the central atom. So central atom here is from group 4, but here no doubt central atom is nitrogen. It has 4 bonded pair of electron and no lone pair. Now hydronium ion, H3O plus, a dative bond. Look at the shape and bond angle of hydronium ion. Hydronium ion, hydronium ion. All the positive ion we ended as neum, em. Okay. Look at the hydronium ion. The water has 2 lone pair. Out of 2 lone pair, oxygen donated one of the lone pair to H plus ion. Look at the drawing first. Oxygen has 2 lone pair. In case of the water molecule, one of the lone pair given to H plus ion, dative bond. This is the positive charged ion, put plus sign on it. Now, can you remember, or can you recall, that shape is similar to this compound, guys. Three bonded pair of electron and one lone pair. Nitrogen has three bonded pair of electron and one lone pair. Similar structure, three bonded pair of electron and one lone pair. What is the shape of ammonia and bond angle of ammonia? We know that. Trigonal, pyramidal. Here same, trigonal, pyramidal, bond angle 107, 107. Three bonded pair of electron and one lone pair. Can you do this question? What is the shape and bond angle of CH3 minus ion and CH3 plus ion? Look at the CH3 minus ion. CH3 carbon make three bonds with hydrogen and having a negative charge. I told you just now, negative charge is nothing but a pair of electrons. So this negative charge, you assume that there is a pair of electrons. So negative charge appear as a pair of electrons. Now look at that. So carbon has three bonded pair of electrons and one lone pair. It quite resembles to ammonia, guys. Look at that. It's resemble to ammonia molecule. Has one lone pair and three bonded pair of electrons. Hydrogen, hydrogen, one more hydrogen. Look at that. Three. Because negative charge is nothing but a pair of electrons. So there is a lone pair bond pair repulsion. It looks similar to ammonia. Three bonded pair of electrons, three bonded pair of electrons, and a lone pair. So you know that. What's the shape? Trigonal, pyramidal, bond angle 107. You know, guys, negative charge carbon is called carbanion. And let's see the positive charge carbon. Shape and bond angle of CH3 plus. Now it's a shape and bond angle of CH3 plus. Carbocation. Positive charge carbon is called carbocation. Carbocation. Shape and bond angle of CH3, a positive charge. So carbon, hydrogen, 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 and a plus charge. I told you just now, positive charge has no electron. Positive charge compound are deficient of electron. So there will be no repulsion between this bonded pair of electron and a positive charge. So if a molecule has a positive charge, ignore that positive charge. Like a pi bond and a double bond, it has no influence on the shape of the molecule and the bond angle. So look at that. It is similar to, try to recall the parent one. It is similar to BF3, guys. Boron trifluoride. Three bonded pair of electron, no lone pair. Carbocation. Methyl carbocation. Methyl. Methyl CC. Carbocation. Very similar to BF3. So we have discussed the shape and bond angle of BF3. Shape is trigonal planar and bond angle is 120 degrees. Same thing. Shape is trigonal pyramidal, trigonal planar, trigonal planar, and a bond angle BA 120 degrees. So just I want to finish my video here, and I will come back with some more example of molecules having ions ions having negative charge or the positive charge. Thanks for watching. Okay.